Okay, I think everyone has joined, so let's begin today's session. Okay, good evening, everyone. A warm welcome to all our enthusiastic learners joining us from India and across the world for Day 5 of World Space Week 2025. I am Komal and I'm delighted to be a host for tonight's session on behalf of Propagation Institute for Advanced Studies. So, before we begin, I want to tell you people some things that during the whole session, your mic would be turned off. So if you have any doubts or queries, please write down in the chat box and we'll take your doubt and queries during the interactive part after the talk finished. So connecting to the World Space Week. As you all know, World Space Week is the world's annual celebration of space science and technology that is organized from 4th of October to 10th of October. So the theme of the year is living in space. It invites us to explore the exciting possibilities of life beyond our planet, that how human can adapt, survive, and thrive in space environment. Over the past 4 days, we delved into astronaut training, citizen science, astrobiology, and stellar phenomena. Today, we continue this journey by understanding real-world challenges of living and adapting in space. So I'll tell you about organizers. The Propagation Institute for Advanced Studies is a global platform connecting students, researchers, and educators in the pursuit of scientific discovery. And we have our collaborator, which is SS Citizen Science Group, which is India's largest citizen science community. Together, we bridge learners and scientists, ensuring curiosity never stop at the classroom. So for today's guest, we are truly honored to welcome Amoli Kakkar ma'am. She is an astronomy educator, citizen scientist, and a dedicated astrophotographer. Amoli ma'am is a certified asteroid hunter and AAVSO Observer, which is American Association of Variable Star Observer. She is inspiring young minds through citizen science and astronomy education. The passion for space outreach has motivated countless students to explore the cosmos and engage with real scientific research. Tonight, Amoli ma'am will guide us through the practical and human challenges of living in space, exploring both the scientific and adaptive strategies required to thrive beyond Earth. So today's topic is all about living in space, challenges and adaptation. So we'll delve into what it truly makes for human to survive in the harsh environment of space. From microgravity to radiation, physiological adaptation to technological solution, ma'am will walk us through the fascinating realities and innovation that make life possible beyond planet. So I'd like to invite ma'am with a very warm virtual welcome. And ma'am, the stage is yours. You can begin the session. Thank you so much.
I think you're muted.
Ma'am, your mic. Yes, ma'am. Muted.
Thank you, Komal, for the great introduction. I think so. We should not waste any time. Let me share my screen. And I start with my presentation. I hope it's visible to you all.
Yes, ma'am, it's visible.
Okay, great. Right. So the topic says living in space, challenges and adaptations. First of all, I would like to ask all of you, what is the necessity to live in space? Why are we thinking to go about in space to live? My screen is stuck. It's not working. Just a second. I'll just stop sharing once and then I'll do it again. Sorry.
No problem.
Not for the full screen. Okay. So I hope it's visible now to all of you.
And I think you can cut
Yes,
that
sir.
meet extension off so people can view it nicely.
I'll bring it down. I think so. It's okay. No problem. Okay. So, yeah, I was talking about what is the actual necessity of living in space? Why are we so much encouraged to live in space? So, the first point, necessity of space habitation. The main reason could be the excessive population. You know, it is estimated that by 2050, there could be a population explosion of about 10 billion people living on Earth. And that is a huge number. As we all know that India is already is the country who has the largest number of people. So we know what the situation is when there is so many people living in a small area. The resources are limited. So the number of people increase, the resources deplete faster. And living in space can become something viable for humanity's future, because you can make your habitats according to what the necessities you have. You can prevent the environmental challenges which you are facing here. You definitely, there are challenges living in space. You have to consider all that. But establishing the habitats beyond our planet could provide some sort of environmental challenges, solutions to the environmental challenges, and they can expand our prospects for the survival. Otherwise, like these days, as the population outburst is there, we are depleting the sources so fast that we may end up with all the natural resources. So what next? Now, reasons for living in space. Reasons for living in space could be, sorry. Yeah. Just a sec. The first thing, as I said, overpopulation. We know that I already told you that around 2050, our human race would be around 10 billion people. And 10 billion people is a lot. So space habitats could actually provide a solution for the overpopulation challenges, right? The next point could be resource depletion. As the population increases, the resources deplete faster. And when the resources deplete, there is a degradation in the environment which we are used to living in. That is degraded. We already know about the ozone layer depletion. We already know about the rise in the sea level. We already know about the global warming. This is all due to deforestation and the pollution which we have created. So this can provide us a solution to we are thinking that it can be helpful for us to save the humanity, to save the human species, to survive somewhere else. If we survive somewhere else, it would be better. So the next point could be, the main thing, climate change. I already mentioned that climate change. We are already witnessing that the monsoon in India has extended and it is limitless. We have seen the forest and the hills fall in Uttarakhand. So this is all due to the climate change. Then we can talk about the technological advancements. Now, when we talk about the technological advancements, this can include, like, we know that we are capable of going into space. We know that we are capable of researching on a planet such as Mars. We do researches on Moon also. But are we capable enough to stay there? Are we capable enough to sustain on Moon or on Mars, for example? No, not yet. But yes, technology is advancing soon, and we are trying our level best to make such a technology work so that we are able to sustain ourselves on other planets besides Earth. Then we can talk about exploration and discovery. Yes, this is a very interesting fact. Why we need to move out in space. We need to stay in space. We need to sustain in space so that, the exploration and discovery can be easy. On Earth, you have many hindrances. The first and the foremost hindrance is the atmosphere. Secondly, the pollution. Third, it can be that once when you are there on a hostile planet, you can come to know how the planet behaves when there is no one to disturb that particular environment, how the things are moving on that particular planet. So establishing a presence beyond Earth will satisfy our curiosity also, and it opens new avenues for the scientific research also. Now I move ahead to one more topic called as the milestones. See, we have been doing space exploration from so many years, around 75 years, around 60 years rather. So the first milestone was 1957, the day when we start our World Space Week. That is 4th of October. That is the launch of Sputnik 1, where we just tried to go around the Earth. The next is actually 1969, when Apollo 11 was successfully landed on Moon with humans. So that was a remarkable achievement which we had. The next was 1998, when the construction of the ISS began. So this was a very huge milestone after the humans went into space, because we humans tried to stay in a controlled environment where everything was packed in a small capsule, where everything was limited, the resources are limited, water is limited, the oxygen is limited, so everything has to be recycled. So we are getting used to how we will be able to survive or sustain ourselves in the foreign planet, on the foreign planet rather. Then comes the launch of the Dragon crew by SpaceX, which we know that was a commercial flight where the humans paid and went to space and then came back. So this was an event which we are really thinking about, so that we can preserve our resources. Making a rocket again and again to take a human to the space is not so easy. It is really, really expensive. And you may also conduct some kind of mistakes. So to overcome those mistakes and to overcome the expenses, this was a great step. Now in 2030, as we all know that we are planning so that the people or the humans are able to sustain themselves on the moon or on Mars, mostly on moon. Why? Because moon, the first thing, it is very close to Earth. Secondly, we know about the conditions on moon because humans have already gone on moon. We know what the moon looks like, what it feels like, that dust, everything we know. About 50% of the moon we are knowing about it. So listening and taking care of each and every step is really important when we are planning for something in the future. We need to take care about the first thing is the health. The people who are sent to the places where other than Earth, they are supposed to sustain there. So to sustain their health should be perfect. The things which we are providing them, they should be able to sustain in those particular things. So coming back to the, sorry. Yeah. Now, because we are planning to send the people to the moon and to the Mars, what actually could be the benefits? We can access new resources. Like we say that here the resources on Earth are depleting. So we can get the new kind of minerals over there. The minerals which we have already depleted on Earth could be available on Moon or on Mars. Then we could do some kind of scientific researches also. Then there is a potential for new technologies. Obviously, when you are planning to sustain human life on other planets, then your technologies have to be quite advanced, not like they are right now. And also the expansion of the human presence. Then comes the challenges of living in space. See, the challenges are many challenges. What is the first challenge? The first challenge says life support systems. See, we basically humans need three things: air, water, and food in a closed environment. So providing of air, which is reusable, water again, which is recyclable, and food. Food is the basic need. See, if you are planning to go to a other planet other than Earth, you need to grow food over there. And that food which you grow will be in a controlled environment. You will not grow food, you will not grow the crops on the land over there. You will take some materials to grow the food in the controlled environment. And that environment, you have to be well prepared for that. How to recycle the air for a longer time, how to recycle water for a longer time, not recycle air, but how to take out oxygen from the air present there. Okay, so these things need to be kept in mind. Then we have the psychological effects. See, humans are a social animal. We are social. If we do not talk to anyone, we feel depressed. We need to express ourselves. We need to hear from others. So we need interaction. So mental health challenges could be faced by astronauts when they are kept in isolation and confinement. So we have to make them already trained on Earth itself before they are sent to the other planet. Then cost of space travel, as I already mentioned, the cost of space travel is immense. So you need collaborators, you need quite good infrastructure so that we can collaborate and bring about something good in a limited amount of finances spent. So cost of space travel is quite high. Sustainability of habitats. Now, need for long-term solutions for living quarters and resources on other planets. See, when you are on some other planet, you won't be staying out there in open, or you won't be surviving in your capsule through which you went to that particular planet. You need a permanent habitat to stay in. And that habitat needs water, needs air, needs food. So all these things combined. See, if you are planning to go to suppose you are planning to go to a trip. So you already plan what things you need to go to take with you and what things you will get from there. Accordingly, we have to plan ourselves. We have to be ready with all those solutions. Like we cannot build huge quarters to stay in the exoplanets or the different planets other than Earth. So the resources are limited, and the people who are helping us will make sure that the place in which we will be staying on the other planet will be comfortable. We will have place to move, we will have place to read, we will have place to grow our food items. So these are the things which we need to take care of. And then we can think about research and development on the planet which we are placed. Like when we go on a different planet to stay, we have to plan for technological advancements, because these technological advancements will only help us support our sustainability in those different conditions, in those the extreme conditions over there. Then we need to make some prototypes. Like we will be staying in a kind of a dome kind of a thing on other planet. So we need to at least practice staying in that kind of a condition before we actually go and stay there, right? So then comes infrastructure and planning. Definitely, what things will be needed, how many rooms, how many cottages, and what all will be needed to stay there. What could be the transportation mode on that particular planet? Like we have already sent the Mars rovers. Similarly, moving on a different planet is not as easy as moving on Earth because of the gravity, because of other conditions over there. So we need to manage that too. Then we have some initial missions like the Artemis, which we already started conducting. These missions, the Artemis mission, actually, the first mission was that how the spacecraft would go around the body. In the second mission, the humans were taken around in space. And in the third mission, which is due to be conducted, they are planning what kind of homes or what kind of habitat will be made over there. Will they be made on Earth and then assembled on the planet or on Moon, or they will be taken in a very raw form and assembled over there? So these are the basic planning which we need to do before stepping out in space, because we are really comfortable on Earth. We do not know what space has to offer. It is very, very unpredictable. Now, expansion. Definitely, if humans are able to live in a different or a different environment, then definitely we are expanding. Our human race would be expanding, and we will be definitely building up some sustainable ecosystems. Now, why is living in space is essential for humanity's future? Actually, as I started my talk, we said that we are already facing challenges due to overpopulation, due to change in climate, and due to depletion of the resources. So establishing human habitats in space could provide us new opportunities for survival, for researches, for exploration, etc. And I have kept my talk little, very small. So I would like to end by saying that the earth is obviously the cradle of humanity, but cannot stay in the cradle forever. Okay, I'm so sorry. I'm so sorry. I'm so sorry. Is it okay now? Is it okay? Okay. Okay. Is this okay? Yeah, but I have, but I have already ended my presentation. If you want that, okay, just a sec. I'll stop sharing, and then if you want something to be done, I have one more presentation ready with me in which I can speak something. But yes, I would like to keep it low. I just wanted so that the basics, we have heard so many presenters talk all those scientific things. Definitely those are required in detail, but there are some listeners in our group who are just starting to learn what is living in space like. So I just kept my talk very subtle, non-scientific, just a brief of what it would be like living in space, what challenges and what kind of adaptations we would need to have. Yeah.
Uh, Thank you so much, ma'am, Amoli ma'am, for that inspiring and insightful session. Your guidance has truly brought the challenges and adaptation of space life closer to us. So, ma'am, we'll move to the interactive part. Uh, I think people have doubts. A lot of people have doubts. So, first, I'll take some doubt from chat. Ma'am, the first doubt is asked by Vanshika Kumari. She asked, if we live on Mars, there is barely very less gravity and it comes under the gravitational force of Earth. So if any destruction happens on Earth, it directly affects the moon.
Affects the
Moon.
She is talking about Mars or she is talking about moon?
Ma'am, she's talking about moon. Yes, ma'am, she's talking about moon.
She's kindly repeat the question, please.
Uh, Ma'am, I think this is not a question, but she made a statement when you talk
Okay.
about the.
See,
Okay.
definitely anything which happens on Earth, uh, the people who will be staying on moon will be affected by that, will definitely be affected by that. If Earth is hit by an asteroid, for example, so the people who are sustaining on the moon will be affected, because we never know the people who are on moon, their relatives are abiding where are they residing. So definitely it gives a psychological impact on the people who are staying somewhere else, because we have been born and brought up on Earth, and we are used to the environment of Earth. So staying in a different environment is not easy. We have psychological challenges, we have mental challenges, we have other situational challenges also. Medical is not easy, food is not easy, water is not easy, nothing is easy. So we have to be mentally very strong before leaping out in space.
Okay, thank you, ma'am. The next question is asked by Altaf Sayyed. He asked, if we somehow reach any planet, what could be the first thing we do? Mining, construction, farming, etc.
I think so. The first thing which we need to do after reaching out a new planet would be to make a home for us, because we need to protect ourselves from the radiation. The radiation is a very harmful thing which we actually do not experience on Earth just because of our atmosphere. And making a suitable and a comfortable home, even a small dome would work, because we have to, like, we humans, we know that we have to sleep at times, we have to wake up at some time. So taking rest, taking mental peace is really important. So I think so the home is the first thing which is required. Yes, food comes along, but we know that if we are going to some other planet, we will be carrying something with us to eat. We will be carrying some amount of water with us to have. So these things, oxygen management is really, really important, right? Oxygen management and home. These two things, according to me, are the first priorities.
Oh, okay, ma'am. And the next question is by Atufa. She asks, what kind of technological advancement do you think humans need first to make living on Mars possible?
See, technological advancements are really required. 3D printing, because carrying everything to anything to everything from Earth to any X-planet is really, really impossible, because we need to make things light in weight. जितनी हल्की होंगी उतना हमारे को लेके जाना आसान है. It's easy for us to carry them. Secondly, all those things which we need to carry from Earth to transport from Earth to the X planet will require space. So we have limited space in the the capsule through which we are going. So we need to be prepared. How are we going to manage there? Everything has to be practiced on Earth before leaving Earth, before residing on some other planet. So technological advancements are really, really necessary. Maybe it is 3D printing, maybe it is good communication. See, communicating from Mars to Earth or from Moon to Earth, it's not easy, it's time consuming. If you are sending message from Mars to Earth, you will have a lag. You will not be communicating as we are communicating these days on Earth. It will not be so quick. It will not be so swift. The reply would be coming, but it will take time. So you have to be well prepared for all those things. You have to have a good signaling. You have to have good, the basic, what we call the basic structure for staying and sustaining on a different planet. So technology is definitely important. And here comes the role for the AI and ML students, or the AI and ML the contributors.
Yeah. Thank you, ma'am. Then, yes, ma'am. The next question is asked by Liloon. Sorry, I can't pronounce your name. Sorry if I pronounce it wrong. The question is, should there be limits on how long humans can stay in space, given the potential health risks?
Definitely. See, there in the beginning, then humans start sustaining themselves on some other areas except Earth. There has to be a limit, because the astronauts who are staying on the ISS are facing the problems of muscle dystrophy. They are facing the problem of bone degeneration. So all these things have to be taken in consideration. As it is, we are humans, and no doubt anyone who is very, very healthy is sent to the X planet, wherever they have been planned. But health-wise, definitely a limited time period would be suggested until and unless we humans settle there for about a few decades. Till that time, there will be a come and go situation from one planet to Earth.
Okay, thank you, ma'am. The next question is asked by Gayatri. Ma'am, can you explain about moon is experiencing a form of corrosion, hematite formation?
I'm really sorry, your voice is not clear.
Ma'am, she asked, can you explain about moon is experiencing a form of corrosion, hematite formation?
I think so. She's making a statement. It's not a question. I really don't get it.
Okay, ma'am, move to the next question.
Okay.
Soham asks, are centrifugal launches like spin launch practical for launching cargo ships on Moon or Mars?
See, I'm not a technical person, Soham. I'm really sorry. I won't be able to answer that. I am a science enthusiast, and I'm really sorry. I won't be able to answer that. The spin thing, and no, I can't.
Okay, the next question is asked by Abhinav. If we ever find another Earth-like planet, do you think humans would repeat the same mistake that damaged our Earth, or would we learn from them?
I think so. We should not. We really should not. We have to be very alert while habitating other planet. We have to be very conscious because we have already spoiled our blue planet, our blue Earth. It is so beautiful when you look from the space. I really hope we don't repeat the same mistake. We have to be really conscious and really alert before going and staying on any other planet.
I ask people who have doubts, raise your hand, and then we'll ask one by one. The first, Yashwinath. Yashwinath, you can turn on your mic and you can kindly ask your question. Yashnath, you can unmute yourself.
Ma'am, it's actually Yashwant, not Yashwant.
Okay.
Sorry.
Yes, sure.
Okay. Ma'am, my question is that how important are analog missions for real-life experience in space?
Analog missions. I think so. Analog missions really give you a insight that what kind of conditions would you be facing on a unknown planet. You actually see, if you go to Moon or if you go to Mars, you actually don't know what kind of conditions would you be having there. Although our rovers are there on Mars, although humans have already gone on Moon, we have a little knowledge, but every day is a new day. You cannot predict anything. What kind of conditions would you be having? So I think so you have to be well prepared for that.
For many of the analog missions, like which after previous class I researched about it, they are supposed to be Martian or lunar analog missions. But in many cases, the situations accordingly are not sufficient. Like in many instances, the gravity of Moon or Mars are not being adjusted in those analog missions. So, I think this will be a factor that will affect the real purpose of analog missions.
Gravity is a factor which we cannot change on Earth. It is really difficult, right? So that factor will always remain as it is. That we have to go and face it. But mentally and physically, we need to be so strong while going to the other planet that we are. That is why the analog astronauts are given the training of microgravity. That is the reason, right?
Like in many analog programs that I came through, don't have such 0G to 10G like training one.
I can't comment on that.
I came across many programs after previous class. So then
Okay.
I found out the structure of these analog machines are designed in such a way that they are not 100% fulfilling the requirement.
Definitely. See, living on Earth, you cannot exactly replicate what you will find on the other planet. You cannot 100% replicate. You are trying your level best. You are trying to achieve what conditions could be found there. So you are just trying. That is why technology advancement is required.
Okay, like now I got it. Thank you.
Okay. The next I ask Tanuja, you can unmute yourself and you can turn on your camera.
Tanuja, you are on mute. Yeah.
Yes, ma'am. Actually, my name is Aditya. And first of all,
Aditya.
thank you for such an informative session. My question is that, according to, on the basis of technological advancements, when the humankind will be able to do the exoplanetary missions and will be able to establish habitations on other planets, not only in our solar system but also in the other exoplanets which are like far more away from us, then according to the scale of that, that is very actually popular on going on right now, that is type 1 and type 2 civilization types, then what kind of civilization would we be?
See, it is really unpredictable, and this is a really hypothetical question which you are asking. We haven't yet stepped out of Earth. So planning for the exoplanet habitation is really, really difficult. We cannot plan it right now. First, we need to plan it to stay on Mars or on Moon. First of all, on Moon, right? So we need to get ready for that. Only then we can plan to stay on exoplanets, right? First, we need to sustain over there. We say that there is always a first step. We need to take the first step, only then we can climb up the stairs. You are just saying that on top of the building, this is there, so how do I reach there? How do I stay there? You cannot stay there directly. We have to go step by step. The first step was taking a leap in the space. The second was like building the ISS and humans staying on the ISS. So we need to move step by step. Definitely it will take time, but maybe definitely you'll hear something, maybe not in your age or somebody else's age. Definitely humans may habitat, stay on some kind of an exoplanet.
Okay, ma'am. Thank you.
Yeah.
Okay. The next I'll ask Abhinav, you can unmute yourself and you can kindly ask your question.
Hello, ma'am. Am I audible?
Yeah.
Okay.
First of all, thank you, ma'am, for such a pleasantful interaction. I really enjoyed the session. My doubt is that, do you think that the Earth itself might someday recover naturally from the damage that humans caused, or we will reach a point where it's too late?
See, Earth can recover itself. As humans, if you know that our individual body, our own body, repairs ourselves time and again, right? Similarly,
Yeah.
nature has a thing that it can also repair itself, but it will need time. We all went through the corona phase, right? There
Yes.
was lockdown all over the world, and there were videos and images of wild animals roaming around in the cities. right? So how did that happen? The wild animals weren't scared because they didn't see anyone roaming around. They thought that it was all barren. It was all for the animals to roam around. It was a jungle for them, although a cemented jungle. So in time to come, if we stop pollution, if we stop deforestation, all these things, if we have a control on the climate, see, control on climate is really lost because we have the sea levels rising, we have the monsoons increasing, we have too much cold of winters. So control on climate is really lost. But still, if we try hard to make Earth a better place to live in, definitely this is the best place for humans to stay alive.
Okay, thank you, ma'am.
Ma'am, there are few questions in the chat asked by Nazia Jamal's. Future catastrophe that can lead to Mars-like situation of Earth.
Which catastrophe?
Future catastrophe, ma'am.
See, Mars-like situation on Earth or Venus-like situation on Earth can happen if we do not control our exploitation of the Earth resources. The first thing. We have already depleted many of our petroleum sources. That is why we are slowly shifting towards the solar fueling. So slowly and steadily, we have been depleting our resources. The resources are the thing which needs to be replenished with time. It will take time. They cannot be replenished overnight. If you are using something, that is why the people say that if you cut one tree, plant at least 5, because those trees need to grow up. And when they grow up, only then you will be able to bear the fruit from them. So it takes time. So definitely conditions on Mars can occur on Earth also, but we need to take steps. I really don't want to think of that kind of a situation occurring on Earth. But yes, if we start punishing our Earth so badly, then that time is also not so far away.
Yeah, ma'am, I agree with your statement. That is very true. Ma'am, the next question is by Samsu Luga. MOXIE on the Perseverance rover converts Mars carbon dioxide into oxygen. And how effective is this technology, you think? Could it work on other planets? And to what extent could future human missions depend on it for breathable oxygen?
See, for breathable oxygen, right now on Mars, there is no human. It is just a trial. You know, as I already mentioned, that we have to be well prepared. We are doing the experiments to sustain humans on other planets. So it is just a trial. How it can convert hydrogen to oxygen or how it can convert methane to oxygen. So yes, these processes take time. And see, it is not that once you can convert it, you will have the result same all the time. It is just trial and trial and trial. Yes, this kind of a instrument can be helpful for the future missions of humans in outer planets, in the other planets, if we are trying to sustain ourselves. Definitely. But I would also like to add that technology advancements will happen before we step out into the space. Humans, when they are planning to stay on other planets or on moon, definitely we will try to figure out many things before stepping out.
Okay, ma'am, the next question is asked by Mani. At present, the technology we have may take a generation of time to leave solar system. Is there any intergenerational traveling plan on table at present time?
Intergenerational traveling plan. I really don't know about that. I really don't know that. No, I can't comment on that.
So, okay, ma'am, if anyone have any other doubts,
Because leaving the solar system, we have only two objects of humanities which have left the solar system, that is Voyager 1 and Voyager 2. So it is really difficult to say right now. It is really, humans haven't crossed Mars. We haven't gone past Mars. We are trying to go to Mars. We are trying to go to other planets. We have just reached the moon. So talking about generation leap or intergenerational traveling is, see, these kind of situations are really, really hypothetical right now. Maybe they will be in future, they will be visible to all of us. We would be talking about all those things. Definitely the movies which are being made these days are showing all these things, but it's really very soon to predict all those things, right?
Jiventika, you can unmute yourself and you can ask your question. Hello, Jiventika. I think she's
Question
not
is, there is also moon, Jupiter moon, that is Europa, that is also similar to the Earth-like, but we mostly see that most mission are planned for moon, either moon, Venus or Mars, but not considering the Europa. It is also having the similar situation as Earth. So first, the habitability can be possible there also.
See, Europa is definitely solid, but it doesn't have Earth-like conditions. The sea over there or the water over there is not H2O. It is methane. It is methane in liquid form. So you cannot comment that it is Europa where you can plan to stay. But definitely, we are searching for planets. We are searching for moons where we can, as a humanity, can go and thrive.
Means that the moon has more chances to have the habitability. You mean to say that?
See, only the moon is not the thing. We are planning to have the habitability on Mars also. But the first step will be definitely moon, because the first thing is that it is very close to us. Secondly, we are much familiar with the environment of the moon rather than of Mars. Secondly, the next point would be that for Mars, you need to first be comfortable staying on moon. First, you can sustain on moon, only then you can take the next step. Mars is very far off and moon is quite near to us. So I think so the first step first, we need to go stepwise. We cannot just jump off and like if I find any exoplanet with Earth-like conditions across our solar system, outside our solar system, we cannot plan to just go and stay there. It is not so easy. We have to have proper planning. We need to go step by step. The first thing would be like the humans need to have a habitable or a sustainable environment on moon.
Yes, ma'am. Okay, thank you, ma'am.
Okay.
Okay, ma'am, I think we have gone through all the doubts, and people whose doubt are remain, you can mail to the propagation mail, which can be provided in the group. And now we are at the end to conclude this session. I would like to thank you, ma'am, very much again and again. Thank you so much, ma'am, for inspiring us and giving us very insightful session toward living in space and how we can survive and adapt. Thank you so much.
Thank you.
Before we conclude, I have few announcements. A Google form and a session recording link will be sent to your registered email. And if you will already fill out the form, there is no need to fill it again. And all certificate of will be available after 10th of October. So before we wrap up today's session, let's capture the gathering of space enthusiasts. So please everyone turn on your camera.
So,
Okay. Thank you everyone. Thank you so much for joining on the day 5th of World Space Week.
Thank you.